This is a quick intro video to ArcScene. I've opened ArcScene already and I've activated several toolboxes. I put Arc Toolbox over here. This toolbox is named Tools. That's at the top right. Animation is right here. This toolbox named 3D Analyst is over here on the left. And then the standard toolbar is where it usually is. I've added tack streets and tack hillshade, as well as tack 6 feet 1 harn, but I have turned that off. In order to visualize spatial data in the third dimension along the z-axis, you must tell ArcScene which raster's values will be used to define the heights of your surface. These values don't necessarily need to be elevation values, as you will see very quickly. They can also be measures of any other phenomena that are used to produce a raster surface. In this step, we'll use actual elevation data from tack 6 feet harn raster to set the base height for both the hillshade and the tack streets layer. In doing so, these layers will conform to the topography defined by the elevation map tack 6 feet 1 harn. You can think of this as draping the hillshade and the tack streets onto a three-dimensional map of topography in Old Town Tacoma. To set the base heights for Tacoma hillshades and tack streets, right-click on each layer one at a time, open the Base Heights tab in Properties. I click on the base heights. We're going to choose Floating on a Custom Surface from the Elevation from Surfaces menu. And then we're going to choose Tack 6 foot 1 harn. To do that, I need to get back to my data in my geodatabase. Add. I then must click the Raster Resolution button and change the base surface in cell size X and cell size Y to match the original surface sizes, and that should be 6 feet. Original surface, set that to 6, set this to 6. Doing this will improve the resolution of our 3D model dramatically and make it possible to conduct a finer scale visual analysis of the data. Click OK to exit the Raster Surface Resolution dialog, but before clicking OK to exit the Layer Properties dialog, adjust the symbology in the Symbology tab for each layer. Click on Symbology. And this is, of course, for tack streets. I'm going to show a single symbol. I'm going to go with Mars Red, single symbol 1, and set the transparency under the display to about 70%, and then apply. And I'll hit OK. And I've set the streets. While this runs, I'll pause. The base heights for tack hillshade looks a little different because we're working on a raster, but once I click base heights, it looks right. Floating on a custom surface, I go back to tack 6 feet harn, say OK. The raster resolution will again go back to 6, and I'll say OK. And clicking in Symbology, I'm going to show stretched. The color ramp is brown light to dark. I'm going to right click, turn off graphic view, and search for brown light to dark. Within the stretch down below, I will keep it on standard deviations, n equal 2, but I will choose invert. Also for tack hillshade, I'm going to click on the rendering tab and check the shade aerial features relative to the scene's light position checkbox, which is right here. Doing this will enable us to adjust the position of the sun in this model so that it is possible to model shadows depending on the time of day. I click OK, and after a little bit of time, my layers are now rendered in 3D. Once your scene comes to life, you should be able to see some sort of 3D effect. I highly encourage you to practice right now with the tools. For example, this is the Navigate tool. Try spinning the map, which is unique to ArcScene. It doesn't happen in ArcMap. Clicking and spinning the map. Notice what happens when I go up and down, but for right now I'm just grabbing and slowly turning. Again, up, down, left, right. Stopping. Click the zoom in tool. And you have to be very careful because it does take a while. And then perhaps the pan tool to get it to where you want. Go back to the navigation tool. Tilt it some. You can go down, up, and play with it a little bit, and then when you're done playing with it, stop, click on the full extent tool, and it goes back to the original. That's a good way to get back to where you started. It is also possible to exaggerate the vertical dimension of your layers by adjusting the scene property settings, which we'll do in the next step. Right-click on Scene Layers in your table of contexts and click Scene Properties. This is similar to looking at the data frame properties. Click on the General tab if it isn't already there. And next to the Vertical Exaggeration drop-down menu, click Calculate from Extent. The number that appears in the drop-down menu field is the factor by which the z values or elevation values will be multiplied in order for the vertical dimension of your map to be visible when it is zoomed out to the full extent. Click OK to exit the Scene Properties dialog and notice the base heights of your scene have been exaggerated. I click OK and we wait a little, and now you can notice on my map and hopefully your map that it's been exaggerated. Now would be a good time to practice getting back to that same location. I use the Navigate tool, then the Zoom In tool, and wait while it works, and then perhaps back to the Navigate tool, look down in the valley, and then I can stop. Play around with these tools 1, 2, 3, 4, 5, 6, 7, 8, and 9 from this one to this one to get a hang of what they do. You'll also be asked in your write-up to describe what each of them do in your own words. Moving on, to adjust the location of the simulated light in the model, right-click on the Scene Layers again. to open up the Scene Properties dialog. In the dialog, click the Illumination tab. There are three primary tools in this tab. Azimuth adjusts the angle of the simulated light. This range begins at 0 degrees north and ends at 360 degrees north. To adjust the azimuth, you can enter a value in the text field in the azimuth box, or you can drag the sun, the yellow ball, around the compass. Notice that as you make adjustments to the azimuth, the shading on your map changes. So in the azimuth, if I move it, notice how it changes the light on the model. I'm going to restore defaults. The altitude adjusts the altitude or the vertical angle of the simulated light. This range begins at 0 degrees horizontal and ends at 90 degrees vertical. I can grab this and move it, and I'll restore defaults to get back to where we started. Contrast adjusts the contrast between light and dark areas, the shaded regions of your model. 0 is low contrast, while 100 is high contrast. Right now it's on 50. If we bump up the contrast, we can definitely see that. If we dim the contrast, we can see that the contrast is dimmed. I'm going to restore defaults. In this step, we'll adjust the light source so it's coming out of 45 degrees northeast, notice where the sun went to, and 75 degrees altitude. For fine-grained control over the position and scale of your model, you will use the View Settings dialog that is located in the View Settings box. Adjustments in this dialog include observer position X, Y, and Z values. Will rotate your model along the three axes based on the hypothetical position of an observer, U, relative to the model. Set the observer position for your model to X is 1163000, Y 720000, and Z 13,000. Click Apply to apply the new observer position to your scene. Notice how the map changes. Target position X, Y, and Z values of a target that can be used to recenter your map via the Zoom to Target tool. Feel free to experiment with the target position settings, but then adjust the target position to best approximate the image that is included below. The viewing characteristics projection down here in the view settings defines how your map is projected on the screen. Default in ArcScene is perspective. Orthographic is 2D. Let's click on that to see what it does. And there it is. Stereo view, click to see that, allows full 3D viewing, true 3D. View field angle, and the view field angle is right here. Let me go back to perspective. View field angle and roll angle pitch over here. Settings adjust the horizontal roll and vertical pitch line of sight between the observer, you, and the model. Experiment with these adjustments to see what they do. Adjusting these values will impact the observer position setting, so when you're finished experimenting, reset the observer settings to the values above. You can see if I drag it or move it, it definitely adjust the roll and pitch, and then the view field angle also adjust. Be sure to bring these numbers back to what it is written in the lab before you finish this last step. Now that I've got them adjusted, I'm going to close and then save one last time. In this case, it will be Old Town 3D as a scene, and then you will export the map or scene in 2D. My map's Lab 5, Old Town 3D. I saved it first, which means that it will pull up that name for the PNG, and I click Save. And that's how we get started using the different application called ArcScene within ArcGIS Desktop or ArcInfo.